Hello, my name is Mariem and today I'm going to talk about Coccolithophores from the Pacific Ocean. However, I would like to really talk about how I went from wanting to be a micropaleontologist to a micropaleontologist. Dinosaurs are really a cool thing for little girls, but I tell you, Coccolithophores are way more interesting for grown-ups. This is my latest version of the CV. I was born in Spain, studied geology, got a PhD, and then jumped into a series of postdoctoral fixed-term positions that brought me to first Germany and then to the UK. And this postdoctoral fellowship gave me the chance to sail in different expeditions to the Southern Ocean. And in 2022, I was appointed a lecturer at the University of Portsmouth in UK, where I teach micropaleontology-related subjects. I mostly work on the Southern Ocean, which is a big nonsense in my life because I get really seasick. So going to the screaming 60s is a big thing for me. However, the Southern Ocean is a really important key area because relevant dynamics happen in this area. So first we have an upwelling around Antarctica that brings up nutrients and which then flow to the north, and they fuel 75% of the biological productivity north of this ocean. We also have heat absorption, so it takes 75% of the anthropogenic heat, and also the Southern Ocean absorbs approximately 40% of the CO2. Therefore, it has really strong implications in the climate. And only understanding the Southern Ocean dynamics can we then advocate for climate mitigation. That is the key of the story. And to understand how this will affect future environmental changes, we need to look into the two evil twins. First, global warming that makes the ocean more stratified and therefore more difficult to mix, lowering the amount of nutrients and the productivity. Here we can see where we are nowadays. Yep. And 423.68 ppm, and the different scenarios that we can consider for the future. We have the second evil twin, the ocean acidification, that broadly in a very simplistic way implies that with higher amount of CO2, pH will decrease and the ocean will become more acidic, and therefore this will impact calcifying plankton. Since I defended my PhD in 2009, I've been trying to answer part or some of the three main big questions that are: how will the Southern Ocean ecosystem respond to global warming? How resilient is the polar ecosystem to ocean acidification? And how have high-latitude ecosystems responded to warmer conditions in the past? For that, I use Coccolithophores as a proxy. Here we can see how a Coccolithophore dwelling in the Southern Ocean would look at the different oceanic basins. And we all know that Coccolithophores are phytoplanktonic algae, and they are the primary producers driving the food chain. And of course, we cannot forget the double role they do, that is photosynthesizing and calcifying, therefore taking CO2 and releasing CO2. Trying to answer these three main questions, I managed to do some work in the Pacific sector of the Southern Ocean and concluded that living Coccolithophores, they tell us a lot about oceanographic drivers. These are a couple of examples of how the different frontal systems are affecting the distribution of Coccolithophores across the Drake Passage and in the Pacific Southern Ocean, and how numbers did decrease in these hydrographic structures. For example, south of the polar front, numbers drop drastically. I also did some research in the morphotype distribution of Emiliania hartleyii. and the Coccolithophore calcification, which can be linked to ocean acidification, especially in areas where the pH is relatively low. Here we can see some coccospheres that belonging to the morphogroup A, plankton samples, and some examples of different calcification degree in surface sediment, in placcoliths preserved in surface sediments. Of course, I like to study plankton and recent assemblages, but we have a really beautiful geological record that provides examples of past warm intervals that we can use to make inference for the future. And one of these intervals is the marine isotopic stage 11, which happens roughly 500,000 years ago. And this is one of the best analogs we have for future climate. Why is that? Because it has comparable CO2 concentrations and similar orbital configurations. One of these examples, here we can see how massive amount of Capsa-Caribbeanica is happening in this part of the ocean during MIS 11, and the reconstructions for the productivity using geochemistry and micropaleontological approaches suggest that they were really high values, and the biochemistry of the area was affected. My ongoing research focuses on sediments retrieved during IODP expedition 383 that happened we sailed to the Southern Ocean in 2019, and especially in those sites in the central South Pacific, ranging from late Miocene to Holocene, but also in plankton samples retrieved in these latitudinal and longitudinal transects, where we can see a varying degree of Emiliana Huxley morphotypes. My findings during the latest years include Coccolithophores are cooler than dinosaurs, especially in the Southern Ocean. High-latitude Coccolithophores are essential to understand the global systems in the context of, especially in the context of a changing ocean that is affected by global warming and ocean acidification. And for doing this kind of studies, we need to quantify in an accurate way and using creative approaches, new technologies to get really high quality data that we can use in models for the future. Multidisciplinary collaborations are the way to go to the future also, and to get the big picture. IODP is the best example I can think of that. And for the younger and earlier early career scientists, I recommend to seize career opportunities and accept challenges. My career was built on a random invitation to sail to the Southern Ocean first time in 2009, and it has gone very well so far. So anyway, I thank you, and if you have any questions, don't hesitate to write to me in an email or reach in social media. Thank you very much.